Deep beneath the ocean's surface, hidden from our view, lies a world of fire and water. We often think of volcanoes as fiery mountains on land, spewing ash and lava into the sky. But did you know that some of the most powerful and mysterious volcanic activity happens underwater? These submerged giants are responsible for something incredible: underwater volcanic plumes. And now, scientists are starting to wonder, could these plumes be a new disruptor in Earth's climate system? Let's dive in and explore this fascinating phenomenon. Picture the ocean floor, a dark and alien landscape where tectonic plates pull apart or collide. Here, underwater volcanoes, also known as seamounts or hydrothermal vents, erupt in silence. Unlike their terrestrial cousins, these eruptions don't always produce dramatic lava flows. Instead, they release massive plumes of superheated water, gases, and minerals into the ocean. These plumes can rise thousands of feet, carrying heat and chemicals from Earth's interior into the cold, deep sea. So, what exactly are underwater volcanic plumes? When magma from beneath the Earth's crust meets seawater, it triggers explosive reactions. The intense heat, sometimes exceeding 700 degrees Fahrenheit, causes water to boil and form plumes of hot, mineral-rich fluid. These plumes are like underwater geysers, loaded with methane, carbon dioxide, sulfur compounds, and even tiny particles that can affect the ocean's chemistry. Some plumes are so powerful they can spread across vast distances, influencing entire ocean basins. But why should we care about something happening so far below the waves? Well, it turns out these plumes might have a bigger impact on our planet than we ever imagined. Scientists have long studied how land-based volcanoes affect the climate. Eruptions like Mount Pinatubo in 1991 pumped ash and sulfur into the atmosphere, temporarily cooling the planet by reflecting sunlight. Could underwater volcanoes be playing a similar role in the climate puzzle? Let's break it down. One of the biggest questions is how these plumes interact with the ocean's chemistry. The ocean is a massive carbon sink, absorbing about a quarter of the carbon dioxide humans release into the atmosphere. Underwater volcanic plumes release their own gases, including CO2 and methane, which are potent greenhouse gases. While the amounts are small compared to human emissions, they could still alter the ocean's ability to store carbon. If plumes make the water more acidic or change its temperature, it might reduce how much CO2 the ocean can absorb, potentially amplifying global warming. Then there's the heat. Underwater plumes carry enormous amounts of thermal energy from Earth's core. When these plumes rise, they warm the surrounding water, sometimes by several degrees. In small doses, this heat gets dispersed across the vast ocean. But what happens when there's a surge in volcanic activity? Scientists are studying whether large-scale plume events could disrupt ocean currents like the Atlantic meridional overturning circulation, which acts like a global conveyor belt for heat and nutrients. If these currents slow or shift, it could lead to dramatic changes in weather patterns, from stronger storms to altered rainfall. Another piece of the puzzle is the tiny particles in these plumes. Known as aerosols, these microscopic bits of minerals and metals can float in the water for years. Some even make it to the surface where they can interact with the atmosphere. On land, volcanic aerosols can cool the planet by reflecting sunlight. In the ocean, the effect is less clear, but researchers suspect these particles could influence cloud formation or even marine life, which plays a huge role in regulating carbon cycles. Speaking of marine life, underwater plumes create unique ecosystems. Around hydrothermal vents, entire communities of bizarre creatures, like tube worms and heat-loving microbes, thrive in conditions that would kill most organisms. These ecosystems are powered by chemosynthesis, where microbes use the chemicals in plumes to produce energy. But if plume activity ramps up or changes, it could disrupt these delicate ecosystems, affecting the broader food web and the ocean's role in climate regulation. Now let's address the big question. Are underwater volcanic plumes a climate disruptor? The truth is, we don't know yet. The science is still young, and studying the deep ocean is incredibly challenging. Robots and submersibles can only explore tiny patches of the sea floor, and we've mapped less than a quarter of it in detail. What we do know is that underwater volcanoes are far more common than we once thought. There are an estimated 1 million seamounts and vents, and many are active. If their plumes are releasing significant amounts of heat, gases, and particles, they could be a wild card in our climate models. To figure this out, scientists are turning to cutting-edge technology. Deep-sea drones equipped with sensors are mapping plumes in real time. Computer models are simulating how these plumes might affect ocean currents and chemistry. And researchers are even looking at ancient climate records to see if past underwater eruptions left clues in ice cores or sediment layers. The evidence so far suggests that while plumes might not be a primary driver of climate change, they could amplify or complicate the effects of human activity. So what does this mean for the future? If underwater volcanic plumes are indeed a climate disruptor, they could make it harder to predict how Earth will respond to global warming. For example, if plumes warm the oceans or release more greenhouse gases, they might push us closer to tipping points like the collapse of ice sheets or the release of methane from the sea floor. On the flip side, understanding plumes could help us refine climate models, giving us a better shot at preparing for what's ahead. As we continue to explore the deep ocean, we're reminded of how much we still have to learn about our planet. Underwater volcanic plumes are a reminder that Earth is a dynamic, interconnected system where even the deepest, darkest corners can influence the world above. Could they be a new climate disruptor? Only time and science will tell. But one thing is clear. The ocean is full of surprises, and we're just beginning to uncover its secrets.